in terms of items for today, I'm just going to pull it running. The two main things. So we have this SimPEG roadmap. It is here. I'm just going to post my slide.
Roadmap. Great. So where are we going?
Where are we going?
Is it open end? Oh.
So I'm just going to share my screen here.
Whoa.
Cool. Do you guys see that okay?
Yep.
Yeah. Perfect. Yeah, so this is actually kind of cool. What prompted this, we had written out like the SimPEG wish list something like 2 years ago, and then it's just sitting in Google Drive, and Ari, I believe is how you would say his name. I'll have to come correct me. On Slack, just asking if we have a roadmap, which is a great point.
Yeah, the goal.
Yeah, what are you doing? And so with that and tried to like update these things. What's also kind of cool is we actually did make progress on some of the things, which is nice. These other things we didn't.
It's always good to check.
So, and absolutely, like this is open to input and direction, and I think what would be nice to do here is kind of make this flushed out a bit, and then actually post it on the SimPEG website. Make sure you publish it, and can always be edited, and we'll keep it alive. So that's actually the first thing. Yeah, so there's a few things. Like I think we're doing better in terms of community, particularly in terms of communication. Like we're getting better in terms of, I think we need to publicize the Google group. I know people really like that way of interacting.
Right.
Familiar with it. I've never really, I mean, I've subscribed to a few of them, but I've never really engaged.
Yeah, never used them.
Yeah, so it's something we can play around with.
People are into it.
And then what else? So then we have where to find things. So actually, that's a big thing that, in terms of documentation, I think will help. Like Case Rowan has done with examples and sort of just hitting them out a little bit. As well, actually highlighting each of the applications that we have, because right now, like they're all listed, but it's sort of unclear where things are at and how mature they are versus not. So it would be nice to actually have like at least either a little segment or like an entire page on each application. I think eventually an entire page would be nice, but that might be a bit much for now. Is like at least if we could have like when you look at the SimPEG website, you can see electromagnetics, mag, crowds, orbites.
Write a paper. that's the easiest way.
But even like just a picture and the title would actually be better than what we have right now.
Lindsay, could you move the microphone a little bit closer?
Oh yeah, sure. To me, are you having trouble hearing me? Okay.
It's just like you're talking through a cup.
Okay, is that better?
That's much better.
Okay.
Thank you.
Yeah, sorry, I must have had it pointed the wrong way.
Oh, nice. So you're not that much. Oh, okay.
Yeah, so like I think the SimPEG website, we can actually pull out some of the tech from the GeoSci website and use that. It's a little better organized than what's under the hood for the SimPEG site right now. So. Yeah, and then one of the things in terms of examples, and if Rowan's able to jump in, he can fill us in a little bit on this as well, is giving better attribution, both in terms of the packages and the examples. So I think that'll come, like packages, at least my take on it would be the first place to do that would be sort of like at the top of the documentation. So when you hit mag, for instance, like prime contact is DOM, and just make sure that those people are highlighted. And then also in examples, what I think would be kind of cool is to do like what we're doing in GeoSci with the case histories, is like you have a name, you can click on the name, and it takes you to a page with all of the people listed.
Okay.
Andrew, I'm not sure if you've seen that. See if it works. So we have a page, and this is auto-generated just of people who have contributed. And then if you go to case histories, for instance, and pick one like Mount Isa, then the contributors there are listed. So it just makes sure that like people are highlighted. And another thing we can do with a lot of the examples is make sure that there's a citation included if it's like an example from a paper or something like that, to make sure it's clear how to attribute work.
Very cool.
Cool. Yeah, and then joint inversions, and I'll let you talk a bit about this later on too, Dom. So the composite objective functions are like in a place where you can play with them. I think before getting it into dev, I would certainly appreciate like some thoughts and a review from you, from Rowan, and from Joe, because I know you guys have each sort of been involved a little bit in that. Yeah, so just to make sure it's at least more clear enough to sort of have other people jumping in.
Before combo goes into dev.
Yeah.
Not right now, it's still in PR.
Yeah, it's still in a separate PR. So I think it's like reasonably close, but as you were saying, like with cell weights and stuff like that, it would be nice to clean up those things before we get it in.
Yeah.
That's the composite objective function.
Yeah. Yeah, and then it would be nice to start getting, of course, some examples. And so there's the mag one you've talked about. I know Rowan's interested in doing like a Richards plus DC example through Archie's law, which would be nice. So just to show a few things.
One is back to research.
Yeah, cranking out a PhD. Yeah. So discretization, I'm really excited to see how quickly things have been moving here. So this is done now, like we've pulled it out, it's in discretize. Now Joe is jumping in and improving speeds on Octree, which is really exciting. So I haven't heard much from him on that recently, but I know he's been playing around with that.
Can we add stuff to discretize, or is that where does it stuff?
Where does so discretize is now just at github.com simpeg/discretize.
Oh, so you set me up to that discretize.
Yeah. Yeah, so if you go to SimPEG now, it's sitting right here. So any mesh changes and stuff like that are all in here.
I'll go there.
Yeah. And so any like mesh utils reading in UBC or anything like that. Yeah.
Perfect.
Yeah,
and then I've been working on getting the SIL 3D up and running.
how's it going?
It's so div and curl are working. I have some plotting capabilities in there now.
So you could do EM.
Yeah. So I'm running EM simulations on it now.
So can you like now do more like a proper Monte source?
Yeah.
Oh, nice.
Yeah.
That's great.
Which is really cool. So I want to test against the 3D, but it seems to be working. And It actually, like what I've found playing around with it that's really interesting is it seems to be more stable to weird aspect ratios because you're much more honoring the symmetry of the problem.
Right, I think, here's what you think about it. Just, even if you don't divide it, then as you mutual reaction.
Yeah.
It's actually works, meaning like dividing it doesn't quite like matter how you divide it.
Yeah.
It doesn't quite matter that much.
Yeah.
Well, as I can see, like, I'm not sure how like to put a conductivity then if you have a contrast, that's a
Right.
different
That'll
story.
make a mess. But I think like for the casing, for a primary secondary type approach, it's actually like pretty solid because then you simulate a simple background, get the casing right, and then do 3D.
That's pretty cool.
So the main piece that I need to do that though is interpolation now between a 3D sil mesh and a 3D Cartesian. So we don't have that right now.
Yeah.
One of the things, and this would be awesome to see more of your thoughts coming in on this, Sagi, is the boundary conditions and how to implement those in a bit of a general way within discretize.
Well, PML and those kind of things, it's like it's not like quite like GeoSci.xyz or that types of boundaries, which like can modify matrices and boundaries.
Yeah.
Like it's more like it's rather than actually changing your equations. So
Okay.
so it's more like it's more like adding more terms.
Yeah.
Yeah. So yeah. So it's not like it's a little bit different.
Mhm.
Like say putting a mixed boundary condition or whatever natural boundary. That's like a sort of like where we can put it into a mesh class.
Yeah.
As a functions. That one was like makes sense.
Yeah.
But putting a PNL because like it's going to be really different for different formulation.
Yeah.
And so yeah, it's not like it's not a problem of like improving boundary. Well, it's just the implementation.
Yeah.
So yeah, not sure.
Okay.
We could definitely like have some more functionality for like implementing mixed boundary or GeoSci.xyz
Yeah.
timelines or that types of things.
Yeah.
So that's not quite done. So,
Okay.
like, all of the new mesh class like trees and human tensor, they're gonna have things with curls and stuff. So there are quite a few things to be done, I guess. Not for like it's more like absorbing boundary condition you put it in.
Yeah.
That's more like just way of implementation. Yeah, it's not hard. It's just like putting sort of one more terms like a diffusion terms or
Right.
like a couple of cells at the boundaries. So
So it's more so like you're adding something to the right-hand side. Is that true?
Sort
Okay.
of like but you need to put a physical property as well.
Okay.
So it's like sort of both.
Hmm.
Yeah, not only in the right hand side. I remember the final form, but the idea is more like adding sort of kind of one more term
Okay.
to make an artificial diffusion
Yeah.
into
Into the boundaries.
Like
Okay.
they usually use colored cells.
Yeah. Okay. Cool.
It's more like a new some application you have.
Right. So it's problem specific in a lot of ways. Yeah. Okay. Cool.
I guess general.
Yeah. Rowan, are you on the Hangout now?
Yep.
Cool.
Yes.
Welcome.
Yes, thank you.
Yeah, we've been walking through the roadmap here. Yeah, so Joe's been improving a lot with 3 in terms of speed. So that helps with operators, but we still need utils and things like that for actually creating meshes. And just some examples around that, because there's a lot of good stuff in SimPEG for doing that, but it's not necessarily easy to find right now.
Joe is improving like a kind of mesh creation part, like
The operator creation specifically. So he's written a bunch of stuff, like he's taken it down to C++. So that speeds up a lot of things.
that's cool.
Yeah.
Yeah, I don't quite know what the state of that is yet. I haven't checked in with him, but in the next week or so, we can.
Yeah, that would be awesome.
Like, have you really tested the Octave code for like, DCs and is Mike good?
Yeah, Mike's been running the Octave forward pretty regularly. The inverse isn't quite working yet because we don't have a cell graph.
For regularization, you mean on the? For
Yeah. So you can't really regularize on the Octave mesh properly right now. Yeah. Like I don't seem to be. He seems to be quite happy with it working for the DC. Yeah, so like I think that's something that would be nice to be more transparent with and like get a few more examples out there and a few more tests against analytics and stuff like that. Yeah, and like Rowan's run an example on an electric dipole.
Yeah, it works more or less with the. It works with the EM code, the Ford stuff. Fine. It's again just working with the regularization. I think there needs to be a tiny bit of improvements with the interpolation.
Right. Because the interpolation is first order right now.
Yeah, it's nearest neighbor.
Okay.
Oh, right. Well, you mentioned that actually testing that with the hemisphere, with DC hemisphere.
Oh yeah.
Yeah, now we could do that. So we could test with the analytics with the hemisphere case or sphere.
Yeah, so I'd like the octree there as well as the logically rectangular mesh.
Yeah, that would be a great set of examples.
So I think probably all of them.
Yeah.
I'm having trouble hearing Soggy.
Okay. Is that any better?
So if you can develop, like, well, we're testing that example, for instance, we generate the hemisphere, and then you can test for octree and both for logically. Is that logically, what is that logically?
Curvilinear mesh is, it's a logically rectangular non-orthogonal mesh, so that's a mouthful.
Okay, curvilinear mesh. Then if you can have some sort of utilities like a UBC types of utilities that without the topography, then if you can generate the fine, well-discretized mesh for both octree and curvilinear mesh, I think that'll be a good start to have. Then actually useful, people can use it, at least for DC case.
And that would be a great.
As well.
Yeah, absolutely.
I would argue in some ways that almost already there. I mean, last time I used the octree code, I found making the mesh was actually very simple. And it's just it's making sense of when it makes sense to use octree and or the curvilinear kind of, I guess, showcasing the improvement that you get from using these more complicated.
Yeah, I think the biggest thing there is we just need a couple examples in the gallery, I guess. And I actually have one that is hanging on a pull request at some point from November. So we're earlier potentially. So there just needs to be a couple more documented examples to show that this is a possible thing to do.
Yeah.
And I think that set of examples, doing some topography with Octree, Curvy, Tensor, like that is a perfect example for the discretized paper.
Yeah.
Yeah, shows a bunch of meshes, is relatively simple with like doing DC, but demonstrates a lot. So that would be good.
Mm-hmm.
Cool.
Is there anything more you want to highlight in terms of the mesh, Rowan?
No, I think, yeah, mainly creating examples, especially with the octree side of things, contrasting that with curvilinear. I need to talk to Joe about increasing the speed and still making sure that we can edit it so that it's not obfuscated sort of into something that only Joe can touch. And then also the more boundary conditions and sort of working on some of the stuff that Soggy's done, Soggy and Mike, I think, have done on the in the DC problem and making that a bit more accessible.
Yeah, like we need that for curl, like nodal gradient, and
Yeah.
all the operators. So that has not been done.
Right.
Yeah.
Especially for MT, that'll be pretty useful, I guess. I'm not exactly sure how MT is implemented at this point, but the yeah, those functionality will be pretty useful.
Sorry, which functionalities, Sagi?
The boundary conditions, being able to change those, like in the curl, for instance, we don't have that right now.
Yeah, that could be very useful.
Sure. Yeah, well, I think my feeling when I was visiting this East Asian, like the South Asian countries, MT is really big. It's their main application. And then their lack of computational capability, either like both in simulation and inversion. So I think they're mostly using, what was it, Chai's code for inversion. So, but like, it seems like it's pretty hard for them to run the for mulling. I don't know why. But yeah, I think opening like those people, like your MT code, SimPEG MT code, will be pretty useful.
Yeah. No, I mean, I just know that the availability of code is just very limited. So, yeah.
Cool. So the next couple items on the list, minimize, that sort of needs to be thought out again. And hopefully getting it like compatible at least with SciPy optimization. In some cases, it's probably worth us still having our own optimization, but it would be nice to have that flexibility, which we don't currently. And better message outputs. Rowan, do you have comments on the AstroPy side?
Oh, they just have some nice ways to store tables, both in memory as well as output to screen, as well as sort of saving it to a file, and stuff that we don't need to reinvent the wheel on. And yeah, in terms of the minimized code, it just needs to be hit as a once over again. I would say that's like actually like a relatively large project, especially with some of the like we're saving memory sometimes in terms of hitting, like when we ask for the gradient or something, other pieces have already been, like the fields are copied over. And right now that's all in one function call, so we can do that in a decent way. But some of that stuff will need to get rethought if we're breaking them up into other functions. like knowing when the models change, knowing when we can recompute or whatever fields and stuff like that. So just making sure that we don't lose the efficiencies that we've gained when we break this out potentially. And so it's a little bit intricate, that piece.
And Gutney's done some work on actually reusing factors, right, Gutney? Like you produced one factorization?
Yeah, I've been able to save one, and I'm working on trying to save a second one. So reducing from, 6 factorization per inversion iteration down to 4. So
yes, that makes a very big difference.
Yeah, it can potentially be very helpful. And I think as well, it's worth, with this work, with the minimize work, it's worth considering that in the scope of the global problem or the parallelization of.
Yeah, no, I think that's absolutely true. Like this is not tackled at all in isolation. Like it touches basically all pieces.
Yeah.
It's like right at the end of our stack, so it needs to get refactored back into some of the other pieces, especially with the parallelization in the, well, what we've spec'd out as the global problem.
Yeah, and I think too, like I would like to get the combo objective function stuff in first, so that we actually have like, because I went in and touched the minimize code to get that up and running, and there's, I would say it's a first pass of that, but at least it's operating, so it would be to start from there.
Yeah.
Yeah, so mappings is growing to something that is huge. I think it's what, like 2,000 to 3,000 lines of code now in one file, which is really crazy. And so it would be nice to break that out and probably as its own package, because it is useful in its own right. And that also will allow us to do a better job organizing things as well, like specifically pulling out parametric stuff, because there's a lot that can be leveraged between them, like the definition of the arctan function and its derivative will be used in all of the parametric examples. So, like, yeah, getting a little more consistency in that. As well as for things like Archie's law and empirical relations, some of those I think we should put to GeoAnna. So, because they are like analytic functions, and it's handy just to have Archie's law, but then be able to translate that to a mapping in the mappings project. So there's a couple layers I think that'll happen there, and perhaps the first step will just be to move mappings into its own repo, and then we can start sort of pulling it apart.
Yeah, because I think some of the other stuff Lindsay's been working on is, oh, the name is escaping me, in terms of
stuff.
Effective medium theory, yeah. That's not something that really needs to reside in SimPEG, and it's sort of expanding the scope there, but it can potentially reside in something like GeoAnna and then wrapped up into mappings and then put into SimPEG. So everything's working as sort of a mapping there. And that just allows us to also push on these things in a couple different ways. So similar to how Discretize is now spun out, that allowed Joe to jump in there, and Gutney, like, you fixed a bug that can get deployed right away, and sort of it allows us to sort of like keep these things all going on their own tracks without breaking too much in the meantime.
Yeah, it keeps things in scope, which is very helpful. Yeah, we're going to a couple things to expand on, I guess, as needed.
Who's working on? Someone's working on cross gradient.
Not right now. Would you like to work on cross gradient?
I think I did.
Oh, yeah?
I think I did at one point. Don't worry.
all I'm told.
I have some reasons why I need that, but yeah, I could.
That'd be awesome.
And I think we're also at the stage, especially with Lindsay's refactor on the combo objective stuff, that the regularization is in a much better place, that we can actually start building on that and building out to some more of these specific regularization pieces.
Yeah, that'll be exciting to play with. Exciting.
Yeah, I'm really looking forward to hearing people's thoughts on that.
Yeah, I hear that Dom's been doing a lot of work on that. I don't know if you guys have gone through that already.
Not quite
Not
yet.
Okay.
Rowan, do you want to speak to interoperability and the I/O stuff?
Yeah, so I think the big piece here is actually getting more explicit about what we actually want to save when we say save as SimPEG class, or try to pickle it up or something like that. And that is starting to happen through some of this work with properties in terms of documenting things as we go. And I can point you to a talk on that, and maybe give another, or Lindsay, maybe you can give a talk about how that's working in your research as well and how that's helping you. There's also another initiative that I'm involved in with the Global Mining Standards Group in terms of defining an interoperability framework between the general mining packages, those are the GMPs in the mining industry, which is, the initiative is called an open mining format. And we've done some initial work there, and it's starting to get adoption in some of the bigger players in the industry. And so it would be nice if SimPEG could rewrite this, and it's relatively straightforward, I would say. But that should save things like some of the data, for example, but definitely any of our tensor meshes. It won't do octree meshes at the moment. Yeah, drill holes, stuff like that. So that's an ongoing thing that I can probably direct some help towards SimPEG to get us up and going.
That would be very exciting. Yeah, and that sort of leads right into the idea of a command line interface, or making it easier to run batches of simulations. With a lot of the casing stuff I've done, like the way I like to work is to set up the mesh and the simulation in the notebook, because I want to see what I'm doing, but then I need to kick it over to the cluster to run it. So I've been using properties to basically just save everything that I need to, and then go and recreate whatever's needed to run the simulation on the cluster. And so I don't know if I'll have time to get to that today, but I'd be very happy to walk through that at some point. Yeah, so I think there's some stuff in there with just like saving and saving what you need to recreate things like a mesh.
Okay.
And instead of like writing the entire script over and over again, I just have 1 or 2 files. I'll show you very briefly like this sketch of the idea. So like this is how I want to run simulations. Is basically generates my parameters file, which is just like a JSON file that says, my casing is this conductivity, this thickness, whatever. I generate a mesh based on that. So I've written a mesh generator that will take in a casing model and do something sane.
Okay.
I tell it what kind of source I want, which is again just built off of these two. And then I say what I want to save it as. So I build up these guys, and I create the simulation object, and then here I just run it. And because I like running stuff from the IPython terminal too, because then if it crashes, you still have your variables live, and can go figure out why. So this is kind of nice. You can just do run impacts of cell symmetry, and see what happens. So
this is really cool.
Yeah, and I think this lowers the barrier to entry for a lot of people who are trying to use SimPEG on the outside. So I know Dom has been working with some collaborators, and that's more the style that they're familiar with, and like a first step into this ecosystem of actually giving people like executables from the command line and saying, edit this JSON file or config file or whatever, and then just run the code instead of giving them a huge script with all of the pieces in it.
Yeah, that's kind of overwhelming.
Yeah.
So.
Yeah, exactly.
Great. How do you do you have some I/O that you can generate the JSON file? Is it?
It's all based on properties. So like all I do, this is all on my casing research repository. So I'll show you quickly this. We basically have this, like I've got a mesh generator that takes in a cell size x1, which is like my close to the casing part, x2 is outside. And so all I do is basically create my mesh generator and then save all of these, because this is all that I need to recreate my mesh. So I save that to JSON.
Nice.
And then I just load it up on the cluster side. And it's nice because then you can visualize it and like make sure your boundaries far enough away and all that.
It's just like in the property class, there's the I/O that you can upload as a JSON file.
Well, yeah. So all I did for this is I just created a like save that uses that. So if I don't have the directory that I want to save it to in my path, I make it, and then I serialize it and then create the JSON.
So what's the advantage of using a JSON format?
I like it because it's like human readable and it's very easy and like cross compatible on all platforms. So I can show you like what it looks like. Is this just Sigma Air? Is this?
Yeah, that's actually pretty
Layer
good.
is this? So
That's pretty good.
It's a dictionary.
yeah.
It's all it is just a Python or whatever dictionary.
Yeah, so it's very simple, which is nice.
Simple is good.
Yeah, and then like you can interrogate it and figure out why something went wrong. It's because I can see that my Sigma error in this case is I was doing the whole space. So yeah, you can go and inspect those things easily.
Yeah, I think doing like a day on talking about research practices, and like Lindsay, you can talk about maybe how you're setting up a research repository to push on like casing research, and then talking also about how we're like writing LaTeX documents and stuff like that collaboratively and pulling things out as well.
Yeah, that would be very good.
Yeah.
Maybe in like two weeks?
Yeah, that sounds good.
Okay.
No, I like that. I really think that's pretty cool, but I think you should also just keep in mind kind of what we consider to be best practices, and because I mean I think the notebook has a lot of capabilities of sharing and connecting to clusters and running remotely. So that might be something we should also consider.
Yeah, and I tried playing around with that and would love input if anybody's actually gotten it set up and running. But I have yet to actually be able to connect a notebook to our cluster. It might just be the way the UBC cluster is configured, but
I do believe it is how the cluster is configured, or like the UPC cluster. But I also know that it has a lot to do with being able to pickle objects.
Yeah, exactly. And this, I think all we're talking about here is nice ways to serialize things.
Yeah.
That's JSON or a Python pickle. I don't think it really.
It doesn't really matter, but it needs to communicate in the same way on both ends.
Exactly.
That's the important thing.
Exactly.
But I mean, I've used the parallel remote or parallel function in the notebook, and it's pretty. I mean, it's the notebook. It's so simple and sleek.
Yeah.
So it will be very interesting in trying to incorporate that into the SimPEG sphere.
Yeah. Yeah, so in terms of the global problem, we sort of started some ideas there and then got on to other things. But I think,
again, this is waiting a lot on making sure that we can serialize classes properly, and we're getting to that stage. But once we have that, then it will be a lot easier.
yeah, which is exciting. So I guess we're sort of at like 15 minutes left here. Do you guys want to continue through this or jump over to what Dom has been doing on joint?
Yep. Sounds good.
Yeah, I think especially like some of these last ones are like sketching at the future and like sort of show some issues and things that we know that we should be doing, but like higher up in the document there is like that's I would say where we're working on immediately in the near future.
Dom, do you want to speak to just what you're up to with joint version and what your thoughts are so far?
Well, I'm not joint version yet.
Oh, you're working towards it though.
Yeah. Well, I'm very happy with the change to the function for sure. It's so much more compact and clear what's happening. There's just more work to be done on the directives or every time we touch the regularizations, because we need to check if it's a combo, then we need to go one level deeper, which is a check every time. So if your regularization is just a single regularization with NC cell, then it's fine, it's just one layer. But as soon as you start using wires and stacking them, then it all becomes a second level. And so every time you want to touch the directives, change the alphas, change the weights, whatever, then you need a check on it and then go one more inside.
Right.
So that's what I spent most of the time trying to make all the examples and the MDI work.
Yes.
It's just write all those, check that you are a combo objective function, so you need to go one step further inside the regularizations.
Right.
So I don't know if there's a way to.
And because you want to change things like a specific parameter, like an alpha.
Or the epsilons or the norms, right? So every time you want to change those, then you need to go inside the combos.
Yep.
But that's okay. I mean, I think we want to have those norms, but we just need to change those functions.
Yeah. That's something to think about how, like there might be a better way to actually give you hooks on the top level of the combo objective function into things, and perhaps through like naming the objective function pieces or something like that, is that if you want to say like at the end of the iteration, please update the epsilon in my sparse regularization on the X direction.
Yeah.
Yeah.
Because right now it's just indexing. We know where they are because they're ordered that.
Right. But you actually want top level.
Well, I mean,
yeah,
we'll still be going to need to cycle through all of some cycles to the left.
Right.
Yeah, you're right. Right now there's no name.
Yeah.
It's just an order of operation.
Can we get an issue on that on GitHub, and I can put my thoughts down and maybe a bit of a sketch of the code as well that I would see.
Yeah, I'll put a snippet of a directive that requires.
And just like document what the problem is on there.
Yeah, I'll do that now.
That'd be awesome.
What are you trying to join using Rust?
Yeah, so Lindsay and I are talking about doing something easy first, because like if anything, like order of operation is super important, scaling is super important. So instead of doing the cooperative, amplitude and MPI, let's do it joint. So they feed each other, right? Constantly.
Okay.
And they're both going to look at the same, virtually the same amount of numbers.
And your data should be scaled nicely relative to.
Yeah, because amplitude-wise, they're in the same order of magnitude, the same physics, so it should be pretty easy.
Yeah.
But it will give us the ability to nail all the details, the wires, and that would be one. One thing though, guys, I want to share that looks pretty nice. I can share my screen.
Yeah, go for it. If you turn your camera on.
Oh,
Yeah. It should be on the left-hand side.
okay. I got permission to let's see this. After contacting Bolivia, there's this super cool data set, and they give us free access to research, publishing on any of it,
Oh, that's awesome.
and it has everything. We have everything. It's huge. Right now it's 3 gigs of data.
Oh.
Let me find it.
Data is that?
Yeah, let me pull that. It's called the Kivitsa deposit, and we have two time domain airborne EMs, a VTEM and a SkyTEM. We have geology. We have a gravity survey.
Oh,
We have 6 lines of IP and MT,
oh, cool.
Oh.
MAG, and we have a 3D seismic cube.
Whoa.
So
So hold on.
you guys can go nuts.
3D seismic is like it's a shot together, or like it's a just.
It's a pre-sec and a post-sec migrated.
Okay. So that's the like output.
Yeah. So it's a big 3D cube, and
That's
there's a researcher that did at in Finland too. I started talking to everybody separately, and then they all started emailing each other behind the scene. And then I got CC'd on one, and I was like, oh, all these guys know each other. So.
I know that the last guy, Chris Richards.
Okay. Yeah. He's at
Quantum.
yeah, first quantum mineral. Yeah, exactly. And so she published a 3D GoCAD model, which she will send it to me soon.
Oh, nice.
That's the seismic cube. And then there's another guy who did a remnants. So that's why I'm interested in it because they studied remnants. It's in Finnish, but I just need the numbers. So yeah, I don't know. Like you guys are probably not interested in diving into another data set, but I will. I will start putting all this stuff together, see what I have, and then I think our joint paper would be.
That
would be
looks
good.
like
And then we could do joint graph. We could do joint graph mag. Then we could do joint EM mag. You know, there's like a lot of joint that can happen here.
it is a big project.
It is a big project, but we have a 3D model of the deposit, and it's a neat deposit too. It's a really neat deposit.
That's really exciting.
It's like it's exactly what we need. It's a compact body. There's some like folding in it, so it's really neat geometry.
That's cool.
CGI already inverted the airborne,
Yeah.
Oh.
and they gave us the model, so I can show the inversion. But,
We should, and so are we able to put the data publicly? Like, is that okay?
well, yeah. So right now we have free range to like publish anything,
Okay.
but I'm not sure if the
Yeah,
data can go
data-
public. I will have to double check with Bolivia.
Yeah, because it would be nice, like what we could do for now is just make sure that it's up on like the SimPEG storage bucket.
Okay.
We can keep that
Private for now.
And then if we get permission, that would be fantastic.
Yeah.
MT data as well.
Yeah, so there's 6 lines of, let me just load this. There's 6 lines of MT. we'll see it better because they did it when they did the IP survey.
Oh, that's a Titan.
Yeah, it's I think it's a Titan. Gregory, I was just showing them the Kibiza. I haven't told you about this one. It's a neat data set, man. This is the CGI model, the 3D model. So
It's airborne?
That's airborne. Yeah.
Whoa, that looks pretty big. What is it?
This one is connectivity from airborne, but they have like we got dumped a whole bunch of data. Yeah.
Whoa.
I'll open for publication.
Wow.
That's awesome.
So when we're ready for joint inversion, that's going to be our our beast.
That's very exciting.
Yeah, and so I'm not ready to. I haven't pushed anything on the cloud, but I'm really working hard on the combo objective functions
Nice.
for all the regularizations work. So should be done this week, hopefully. Tracking up some bugs.
That's great.
That's it for me.
Cool. Are there any other items we want to bring up before we wrap up? Okay, so then what I would say the potential action items that I would love to hear from you on is if you have thoughts on the SimPEG roadmap, we'll sort of finalize some of that and, well, finalize for now and get it posted on the SimPEG website and get that public. So that would be great.
Sounds good.
Cool. All right, well, see you guys later.
Later. Cool.
Thanks.
for this. Awesome.
Cool. Bye-bye.
See ya.
Bye.
You're back.
Back.
How was it?